let's try this again. There, is that better? There we go. So yeah. Good evening, everybody, and welcome back to the School of Grok with more learning C# for beginners and possibly some interesting stuff for people who already know a bit of C#. If you're a C# expert, then feel free to just hang out in the chat and go, that's not right. You don't do that like that. There's a much better way, and things of that nature, and I promise not to get cross. So yes, we are building a calculator command line application. We are, and we're going down to little mark down in the corner there, and we are going to switch over to here. No, we're going to switch over to, let's open up another one, and we'll do School of Grok code calculator src calculator, and if we do .NET run, and it wants us to put calculator left op right, so if I do 3 plus 3, and it will say 6, so that's working. But we are changing around our code a bit, so we're going to make it so that if I do .NET run 3 plus 3 like that, it will still work, and it will say that's okay, everything's fine, I can understand 3 plus 3 without any spaces. So that's what we're doing. And in order to do that, we have started writing an argument parser. So this is going to, we'll pass in the arguments here, and we will send out the decimal and the operator and the other decimal, so the left and right side, and the operator, so that we can then do sums on it. And then we'll be able to do exciting, interesting things. But when we finished on Tuesday, I was just introducing people to the idea of unit tests. So unit tests are automated tests, coded tests that you can run just to make sure a little bit of your program works. And it's a very, very good way of coding. It's a very good way of making sure that your code works properly. But it's also a very good way of writing new code. If you write the test that you expect your code to pass, before you've written the code to pass it, then you write code until the test passes, and then you go, yay, I've done it. And then you write another test that doesn't pass, and then you write more code that makes that work. So we got our argument parser here, and what we need to do is make it do this stuff here. So let's go into here. So we've got this try parse, and this takes a string array, which is arguments, and sets these out values here. And if it could pass the input, then it returns true, and if it couldn't, then it returns false. So what I'm going to do is I'm going to create another version of this method, and I'm going to give it the same name, try parse, like this, but instead of taking an array of strings, I'm just going to make it take a single string like this, and then that's going to do out decimal left, out char op, and out decimal right, like that. And so you can have two methods with the same name as long as they have different arguments. And so this method here has a string array as its first argument, and this method here has just a string as its first argument. And so what I can do with my try parse up here is I can say, I can copy these lines of code down here, and I'm just going to say return true, like that. And then here I can just say return try parse all out left, out op, and out right. And so this is a really nice way of writing your code, because you can write methods that work with different inputs, because at the moment we're passing in the args array that we get from the command line when the user runs our program, but later on we're going to make calculator interactive, so you actually type into it and press enter and it shows you the answer and then asks you for another sum that you can put in. So we're going to do that. So we're going to have try pass that takes args, and then try pass that just takes a string here, which is just going to be what the user has input. We're doing console.readline to get some input, and then we'll put it in here. Okay, so we've got our argument parser tests over here, and I'm just going to change this and make this 2 + 2, and so you can see that that's now calling that with just a single string, so I don't have to create an array there anymore. Okay, and now I can jump out to here where I've got my tests, and I can run those using .NET test like this, and I get 1 failed because it expected 2. So you can see here that it failed on line 14, and assert.equal failed. It was expecting 2, but it actually got 0. So it's expecting, this is line 14, and you can see we say assert.equal 2 and left. So left should be 2, and if it's not, then that's going to fail. So let's start thinking about how we can pass our input. So we can, if we just use decimal.trypass, and we can see here that there are, we call this overloading. Okay, this thing where you have a method with the same name but different arguments in a class, it's called overloading. So these two methods here are overloads of the trypass method. And the decimal.trypass method here also has overloads. And we get this lovely pop-up thing, which the C# plugin for Visual Studio Code gives us. And it says, okay, so I can take a read-only span of char, or I can take a read-only span of char and some other stuff, or I can take a string, or I can take a string and some other stuff. So what we've got here is a string, but we can work with strings as a read-only span. So we have, what we could do is we could say, okay, go along the string 1 character at a time, saying, is it a number? And then when we've got that bit of the string, we'll cut that off and make a new string. And then we carry on and we say, find the operator, and then we cut that bit of the string off into probably just a char because it's only 1 character. And then we have the second bit and we cut that off into a string. But I'm not going to do that. I'm going to use this read-only span thing. So I'm going to say var span equals args.as span, like that. And I'm going to press Control dot and say using system to bring in the system namespace up at the top there, because as span is an extension method on string, and it turns it into one of these read-only span of char. Okay. The reason it's a read-only span is because in C# you can't change a string. They are called immutable. So if you do something to a string, if you say string.toUpper, it doesn't change the string that you've got. It returns a brand new string with the new value in it. Once you've got a string, you can't change it. That's not entirely true. It is possible to change it, but that's for the evil class, and I'm not doing those yet. So we've got this args.as span. So a read-only span of char works a lot like a string, but we'll talk about the difference in a moment. So then we can say for int I equals 0, I is less than span.length I++. This is our first loop, and this is a for loop, and this is one of the earliest kinds of loop that there is. This for loops have been around for ages, and this for bit here has 3 sections, and they're separated by these semicolons. And the first section says we're going to set some initial state for our loop. So in this case, we're going to create an integer variable called I, and we're going to set it to 0. And then the second part is a test. So this part is saying, make sure that I, whatever it is span less than span.length. And then the last section here changes the state that we set in the first part. So we say I++. So the way this is going to execute is it's going to say, right, I equals 0, execute what's inside the loop. Then when you get to the end, jump up to here, run whatever is in this bit of code here, which is just going to be add 1 to I. So ++ says add 1 to I. Then run this check here. So I is now 1. And if 1 is less than span.length, then go down to here again. Okay? So let's think about what we're doing here. We're going to say if char c equals span I. Okay, so now we've got our char that we can do things with. And so we can say if not char dot is digit c, continue. Okay, so this will say skip anything. The user might have put in stuff that is not a digit. Okay, they might have put in spaces at the start or anything like that. So we say if not char dot is digit c, then we will continue through the loop. Otherwise, we'll say int left start equals 0, int op index equals 0, and int right start equals 0. So we're going to create some variables up there. So we are going to say left start equals I, if left start equals 0, left start equals I. So if we have, let's change that, we'll make that -1. So if we make them all -1, because 0 is a valid index within the string, so we don't want that. So we say if left start equals -1, then left start equals I. So we say this is where it starts. And then we're going to say we're going to continue on like that. And we want to go until we find the operator. Okay, so what we're going to do down here is we're going to say private bool is operator, char C. And then in here, we're going to say return C is plus or minus or times or divide. Okay. So if C is plus or minus or times or divide, then we can say we found an operator, and so the left part of our string if we found the operator, if is operator C, if left start is greater than -1. So now what do we want to do with this? Well, let us grab another, let's create some more spans up here. So we're going to create span char, left span and right span, like that. Okay, so we can declare two variables of the same type by just putting a comma in between them. So this creates two spans, one called left span, one called right span. So we're going to say if left start is greater than 1, then we're going to say left span equals span, and then we're going to slice this span like this, 0, I minus 1. Oh, we need to make that a read-only span. Okay. And we want to set op equal to C. So that's our operator there, like that. And then we're going to set right start is going to be I plus 1. Okay. Actually, we don't need to do that. We can get rid of a lot of this. So we can say left span equals span dot slice 0, I, and right span equals span dot slice I plus 1. Okay, that works better. That's much better. And then once we're done with that, we've now gone, okay, this contains our string. So we're going to say break. So we can break out of the loop at this point. And then we can say if decimal.tryparse left span out left, and we get these red squiggles under left span here. And what this means is that it doesn't know for a fact when we get to this point that left span has actually been assigned. So we could be up here. If we don't actually hit this is operator, if they haven't put in an operator, then there'll be no value in here and C# doesn't know what to do with that. And so what we can do is we can say equals default and equals default in here like that. And then we can say if decimal.tryparse left span and decimal.tryparse right span out right return true. Otherwise, we can just return false. Okay, so now let's go back to our argument parser tests and see if those work. And it does. So our argument parser is now working and saying 2 plus 2 is what I would expect it to be. And so what we can do in here is we can say, we could copy this test here and say parses 2 plus 2 with spaces. And then we can say, put spaces in there like that. And then we can see if that passes as well. And that does pass. So it's decimal.tryparse obviously ignores spaces. Good evening, Rambling Geek. Good to see you. Thanks for stopping by. So we now have a basic argument parser that works quite nicely. So very, very simply, we set these values to some code here. And we set these values to default values here. So 0, the character 0, and 0 on the right. Then we convert our args to this span thing here. And then we have left span and right span to get what's on the left and right of the operator. And then we say if is operator here, then do this. And then we try and pass them. And if that works, it returns true. Otherwise, it returns false. Now we can actually make this a little bit more terse. We can shorten our code a bit, because what we're saying is if this is true, return true, otherwise return false. And so actually we can just replace that with return like that. So we just return that value directly back out of our method here. So another new thing that has been introduced here is this double ampersand. So this here is a Boolean expression. And you see those in if statements or in places or in while statements, which we'll come to, or in places like this where we are combining two Boolean values together and saying if they are both true, then this whole expression here is true. If I wanted to make it so that if either of them worked, I could change that to pipe, which means or, okay? But for and, we use a double ampersand. So this will return true if decimal.tryparse left and decimal.tryparse right are both working. I am using C# version 9 in .NET 5. So we've got this and up here, but down here we've got this C# is plus or minus or asterisk or slash. And this is something called a pattern. So this is a Boolean expression, but this expression down here is a pattern, and this is something that was added in C# 9. So in the old days, I would have had to say something like return C equals plus or C equals minus or C equals times or C equals divide. So that line of code there and that line of code there mean exactly the same thing. In C#9, they added this really nice, terse, short way of saying, is a variable one of these values? And so that replaces this code here. Is that the only place you can use OR with a pattern? No, it's not. You can use it in lots of places. I don't want to dig into them too much now, but you can do things like if object is list or array, for example, or not array, but is list or collection. You can use it in a few places. And it is super handy. You could also, so if you had a number, you could say, so if you've got a decimal D, you can also say if D is greater than 0 and less than 10. Like that, and that works too. So you're basically saying if D is greater than 0 and D is less than 10, but you can mix it together like that as well. The pattern stuff that they added in C#9 is really, really nice. You can do very interesting things with it. Okay, so now we have our argument parser and we have our calculator engine. And so down here in our calculator engine, we can say, we're going to create a field and we're going to say argument parser underscore parser equals new argument parser, like this. Okay. This is a field. So here we've got a function, but because it's inside a class, we call it a method. Here we have a field. So classes, objects, they have functionality, but they also hold data. And they hold data in fields or in properties. And we're just going to look at a field for the time being. So what we're doing here is we're saying there is an argument parser here, and I'm creating it when the instance of this class is created. This will automatically be created. Now, I haven't specified any other things on here. One of the things you can do with fields is you can make them private or public. You can see here that my calculate method is public, and that means it's visible from outside. So things outside calculator engine can call calculate. But parser, I don't want them to do that because I don't want them to know how I'm passing the input. So I've marked that as private so that nobody outside the calculator engine class can see that parser. They can't access that. That's just mine for me to use inside here, not for anybody else. So now in here, I'm just going to change this line of code here to say if not parser dot tryparse args out var left, out var op, and out var right, then we'll write out this usage thing here, and then we can take out this stuff here, and then we can change this to be if op equals, so this is a decimal, and this is a char, and this is another decimal. Okay, so now op is a char. A char is a single character out of a string, and so we can't, when we specify character literal, we have to use single quotes, so we can't mix up our string literals and our character literals. Okay, and then we can change this as well. We could go through and we could change all of this, but I want to look at a different way of writing this if statement, because we've got an if and an else if and an else if and another else if. And there is a nice, easier way of writing a whole bunch of ifs or elses against the same variable, which is called a switch statement. So we're going to say switch op like this, and then we can say case plus colon result equals left plus right, and then we have to put a break in like this. And then I'm going to grab those 3 lines and paste them a few times, and see now it's complaining because you can't have the same case statement twice in a switch statement. So I'm going to change this to a minus, and this to a times, and this to a divide, and this to a minus, and this to a times, and this to a divide like this. And then the last thing, so if it's not any of these, I want to be able to write something else. So I can say default, and this is what to do if the code is the default. Like that. And then down here, I can just say return result. And if I make the result here the same as the return type here, then I can make this, I can say result equals null and break. Okay. So a switch, it's like a whole bunch of if-elses, but it's it's easier to write. It gives you a better idea of what's going on, and it actually is faster in a lot of cases than an if statement. The C# compiler is able to do something different with the code when it compiles it, and it can be turned into faster machine code than using a lot of if-elses. There comes a point where you can have too many cases in a switch statement, and it really slows things down at compile time, but it still runs quite quickly at runtime. So, if I now go back to program here, and I can got my args, so this should theoretically still work. So let's do .NET run 3+3, and that's still coming out at 6, or it's started coming out at 6. So previously that would have said this usage thing here, but with our nice shiny new parser, our 3+3 just works. And if I put a bunch of spaces in here, that will still just work like that. And if I put in a minus, then I will get 0. No, I won't. Why am I not getting 0 out of there? Interesting. So I wonder what's gone wrong there. Let's go and add another test. So we can say fact public void passes 3 minus 3. So I'm going to put a 3 in there and a minus in there and a 3 in there. And that should be 3, and that should be minus, and that should be 3. And then I'm going to run my test out here. And that says that worked. Okay, so I'm going to do a very cheaty thing here. And I'm just going to say console.writeLine string.join args. and the minus apparently gets lost. That's interesting. If I put a minus minus here, oh, it's because I wasn't putting the minus minus in. Somehow that was managing to work until I put the minus in, and then it stopped working. And so if I put my minus minus in, it does work again. So there's no problem inside the code. It was just the way I was running it from the command line. That's fun. Okay, so let's do something a little bit more interesting in here. So what we're going to say is if args.length is greater than 0, we're going to do this bit. And we'll indent this code here, and then we'll just return out. Otherwise, we're going to go into a read, evaluate, print loop. Okay. Now, on Tuesday, I used something called C# REPL, which is a read, evaluate, print loop for the whole of C#. This is just a read, evaluate, print loop for sums. And so what we're going to do is we're going to say console.writeLine, enter Q to quit, and then we're going to say while true, console.write, and we're just going to write, because what I want to do is display a nice symbol at the start of the line, and then the cursor will start flashing after this. And then we can say var sum equals console.readline. So the user will type something in and we can put it in there. And then we can say if sum equals Q, break. So we'll break out of our while loop here. So a while loop is like a for loop, except it just keeps going round and round in circles until the thing in here is not true. But we're just going to say while true, and then we'll break out of it when we want to down here. Then we can say decimal result equals engine dot calculate sum, and then we can say, oh, you mentioned REPL then. I've used that with ESP32. How does it working with C#? Let me show you the C# REPL. So this is the C# REPL, read, evaluate, print loop. And in here I can say, I can type in sort of 6 times 9 and it will just evaluate that as a sum. But I can also say things like, no, so this is installed as a .NET tool. So you do .NET tool install -G C# REPL. Okay. And I can do hello world dot to upper, and look, it gives me IntelliSense and everything in the command line, and so it's showing the values of these things. I can also say var s equals hello world, like that, and that doesn't output anything, but it has actually set that variable s like this, and then I can say s equals s dot to upper, and then s out like that. So if you're wanting to work things out in C#, a line at a time, the C# REPL is a really, really quick and easy way of doing that. I used it on Tuesday to demonstrate why we don't use floating point numbers when we do maths in C#, because floating point numbers say that 4.99 times 5, it's not 24.95, it's 24.949999. So yeah, we don't use them. And then we type exit to quit. Right, so calculate needs an overload as well. So we're going to create an overload of calculate, which just takes a string. And here I'm just going to return calculate new arg, like that. And so this is now just going to call down directly into this method here. So if I go back to here, and then I can say if result is null, console.writeLine didn't understand that, else console.writeLine, and we'll just use an interpolated string and write the result out like this. Okay, so that looks pretty good. So let's see, what are we doing here? We're going to do .NET run, and it says enter Q to quit, and then I can put 4 times 5 equals 20, and 33.3333 times 3 equals 99.9999, and so on and so forth. So that's pretty good. And then if I enter Q, it just quits back out to the command line. But I want to go back in here because I just want to do one other thing. So if I just go it says usage calculator left up right and didn't understand that. And I just want it to say didn't understand that. So I'm going to break out of here. And I'm going to go back into here, and in my argument parser, where's my argument parser? So here we've got this parser.tryparse args, etc. I'm just going to change this so that this just returns null, and then up here we're going to say if result is null, else like this. And so now if I do .NET run -- foobar, then it will say usage calculator left up right. But if I just do .NET run and then I type in foobar, it'll just say didn't understand that. And if I do 3 divided by 4, it'll say 0.75. And if I say 6 times 9, it'll say 54, which is not right. If you've ever watched The Hitchhiker's Guide to the Galaxy or read The Hitchhiker's Guide to the Galaxy, you will know that what do you get if you multiply 6 by 9 comes out as 42. Actually, that's quite a fun thing that we can do with our application, is we can put little Easter eggs in there. Let's put an Easter egg in our application. Well, look at a way that we can do that. So in here, we've got our sum here. And so we could put something in here that says if sum equals life, the universe, and everything, we can say console.writeLine space 42, and then we can continue. So this says go back to the start of the while loop and just do this in here. Okay, so if I now go out and run my .NET run thing again and put life, the universe and everything, it says 42. If I put that in, it will just say didn't understand that. And so that's quite fun. We can put lots of, you could put lots of Easter eggs in there. You might put all sorts of things in there that your application could work with. So let's look at a way that we might do that a little bit, so we could have lots of these things, shall we? Okay. So down here, I'm going to create another class, and I'm going to call it public static class Easter eggs. Okay. And we're going to move that to eastereggs.cs, which is now here. So this is a static class. A static class is one that you can't create instances of. It's just a handy place to keep a bunch of methods together. And so you can put data in there as well. And so in here, I'm going to create a private static read-only dictionary of string and call it eggs. And we're going to say equals new, like this. And then we can initialize this dictionary with some values like this. And we need to do a control dot on here and bring in system.collections.generic. And then we're going to add a public static method on the class as well. So we're going to say public static bool try get egg string input out string question mark egg. Okay. We won't worry about that for the time being. So then in here, we're just going to say return eggs.tryGetValue input, comma, out egg, like that. Okay. So now we can have our data-driven Easter eggs, and it makes it very, very easy for us to add more of these in, and we don't clutter up our program with it in here. So we can just say if, let's put this after the if sum equals q break. So then we can say if Easter eggs dot try get egg sum comma out var egg console dot write line egg and continue, like that. So this means that we don't have to put a whole load of if else statements or a switch statement or anything in here. We can just maintain our Easter eggs class here, and if I want to add more things in there, then I could do that as well. So we could put in what other questions could somebody ask a calculator? How many roads must a man walk down? Equals the answer, my friend is blowing in the wind. if we go back in here and do .NET run again, and we can put how many roads must a man walk down? Life, the universe, and everything. That's working. That's super weird. Why is that not finding that value in there? Because I haven't saved this change here. There we go. I forgot to save my change in Visual Studio Code, so it didn't get applied, so it didn't go in there. So let's quit out of there. So this data structure here, this is a super useful data structure. I use these all over the place in my C# code. This is a dictionary. So we've seen arrays, like the args that are passed into the application, are like an array. And when we reference something in an array, we use its index, like 0, 1, 2, 3, depending on where it is in the list. A dictionary is like an array, but instead of just having a number for the index and it's the position in the array, you have a key and then a value. And the key, in this case, we're using string, but you can use pretty much any type you want to as the key for a dictionary. And so what we're saying is the key is life, the universe, and everything, and the value for that key is 42. And this one, the key is how many roads must a man walk down, and the value is the answer is my friend is blowing in the wind. And so in here we say eggs.tryGetValue, and you can see that here it says string key out string value. And so we pass in input and we say out egg, and so if the key exists in the dictionary, this will return true, and it will set egg to whatever that key value is here. They would have to type in the key exactly to get a match. That is very, very true. And maybe that's something we could look at fixing a bit in the next lesson. We can look at doing fuzzy matching on that or something. That sounds like an interesting project. I think we will look at that in the next lesson. The other thing we're going to look at a bit in the next lesson is this syntax here. So we've got dictionary, and then we've got an angle bracket, like an HTML angle bracket, if you know HTML, and then string, comma, string, and then another angle bracket. These angle brackets in C# mean that dictionary is what's called a generic type. And in C#, a generic type is a type with arguments that give it more types, if that makes sense. So I could have a dictionary of string, comma, int, for example, which would have string keys but int values. And generics in C# are super useful. Version 1 of C# didn't have generics. And so there is still a type in C# called hash table, which is what we used to have to use before we got generics. And hash table, if I say hash table t equals new hash table, and then t dot and if we look at like contains key, so the keys were objects and the values were objects. So if I said this X, then that would just be an object as well. So that's just simple object, doesn't know what type that is at all. Which means when you had a hash table, you could use the wrong kind of thing for the key and it would just let you. You could put the wrong kind of value in there and then it would return the wrong value. There was no way of saying this is the keys need to be strings or the keys need to be integers or the values need to be integers. So generics allow us to say this is like a hash table, but the keys are strings and the values are also strings in this particular instance. And we'll see a lot more generics as we learn more about C#, and we might actually write some of our own classes which are generic that do clever things. But for now, all you need to know is that this is a dictionary where the keys are a string and the values are a string, and what we've done is we've put our Easter eggs in there. And yeah, next week we'll look at a way that we could make that a little bit more forgiving on how they type that in and make it do slightly fuzzy matching, which is when things don't match exactly, but you say, that's okay, we'll just deal with it. Okay, so we now have a calculator that functions like this, but also functions just like this. And if I put 1, 2, 3, 4, 5 times 6, 7, 8, 9, 0, it will do that enormously complicated sum for me. And if I put in how many roads must a man walk down, it'll print out clever things and people will go, oh, Easter eggs, we like Easter eggs. And if I do Q, it will quit out again. And we did that by writing our own argument parser, which goes searching through, turns a string into a span, searches through it to break it up into the various pieces that it needs, and then uses decimal.tryparse to deal with the results out of there. Okay. So that's all for today. That's all for this lesson. We are going next week to continue to work on our calculator. That would be awesome if Doom launched Doom. I would, but then that would possibly involve writing Doom, which could potentially be really scary for beginners C# lessons. So let's not write Doom. So yes, next week we'll carry on working on our calculator. What we're going to do is we're going to make it cope with memory, for example, and be able to push up and down. So like when I'm in PowerShell, if I push up on the arrow, the up arrow on the keyboard, I can go backwards and forwards through all the things that I have previously entered. And I think that might be a nice feature for our C# REPL. So we can do that as well. Yes, history, that's what it's called. So we're going to add that in. And we're also going to add in a thing where if I say 27 times 8 and 216, I want to just be able to put in divided by 2 and then have it go, if you didn't put something before the operator, then we're just going to say use the previous result. Yeah, so that would do 216 divided by 2. So we're going to put that in there as well. So the calculator is going to have to remember what the previous result is. So that's the plan for Tuesday next week. So tune in then, and we will be doing more of this stuff. But until then, that's it for this week. Display an equals as well. So yes, that's a brilliant idea. But yes, so thanks very much for stopping by. If you only caught the end, then you can watch it from the start on Twitch for the next 60 days, I think, or it will be going up on YouTube. I've got to edit the videos and put titles on them and things, and put them on YouTube. Rambling Geek, you were not bugging me, you were asking questions. The whole point of doing this as a live stream on Twitch is that I can have people asking me questions. It's valuable because yeah, I don't know the kind of questions that people want to do. And yeah, David bugs me all the time. If I turned it on, David would be having bananas dancing around on the screen and splashes and people popping up, which I have actually managed to find a way to make that not go onto the recording, but I keep forgetting to push a button, so I didn't turn it on today. I need to push a button or do a thing on my Stream Deck. That's probably what I need to do, actually. So yes, anyway. Yeah, I will be back with this on Tuesday at 8 o'clock UK time next week. But yes, no, in OBS, I've switched to Streamlabs OBS instead. Monday next week at lunchtime, I'll be starting the lunchtime streaming, so that will probably be at 12:30 on Monday for an hour, and then hopefully doing that on Mondays, Wednesdays, and Fridays. And again, if you can't make it live, then you can always catch up with it. It'll be on demand after it's gone out. Apart from that, everybody, thanks again for stopping by and supporting the stream. Really appreciate it. And I'm off to do stuff. Probably watch Loki, because I didn't watch Loki last night. Need to watch Loki. And then I will see you next week. Have a fantastic weekend. Have a great rest of your evening. And take care of yourselves. Cheers, everybody, and good night.